Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at stars and bars. So they are used as a visual representation when we're completing problems involving combinations with either repetition or repeated objects. So let's explain how to use stars and bars through this example. I have 6 identical balls to be placed in 3 bins. How many ways can this be done? So when we're talking about the ways that this can be done, there are 3 bins and I have to put in 6 balls. So I could put in 6 in the first bin and none in the second. I could put, say, 5 in the first bin, 1 in the second, none in the third. We're looking for how many of these possibilities there are. So stars and bars helps us visualize this. The items to be placed are the 6 balls. So what we're going to do is write 6 stars. Obviously, each of these represents one of the balls. Now we're going to use bars to represent the bins, but we're only going to use 2. See, what we can do is put 2 bars here to tell us how many go in each bin. For example, if I put a bar here and here, that means 1 goes in the first bin, 3 in the second bin, and 2 in the third bin. If I put the bar here and here, let's say, there are no objects in the first bin, 4 in the second bin, and 2 in the third bin. So what we're doing in each of these, if I were to write out all of the many possibilities like this, they all have some things in common. They have 6 stars and 2 bars. What makes them different is where I place the bars. So how many different ways can I place the bars? Well, 6 stars and 2 bars, there are 8 spots in total. And of those 8 spots, I have to choose 2 spots for where I put the bars. So 8 choose 2, you can put on your calculator, 8C2 just gives us 28. That's the number of ways that we can do this. And this formula can be used to solve combinations with repetition or repeated objects. So N here is the number of stars, R is the number of bars. You can use this formula here to find out how many combinations there are. Of course, N and R, what they mean depends on the question. In this question, the stars, N represented the balls and R represented the bins. But hopefully what you can see is this question is basically just asking us how many ways can we add 3 non-negative integers to get up to 6. And that's a question we'll look at more now. So a similar question here, how many non-negative integer solutions are there to the equation x1 plus x2 plus x3 plus x4 equals 12? Now this is pretty much the same as what we did in the previous slide. It's just like these here are our bins. Each number represents how many balls go into the bin. So this is equivalent to saying now I have 4 bins and I have 12 balls. How many ways can I distribute the 12 identical balls into each of these 4 bins? So again, when we're talking about like solutions here or a particular arrangement, it's something like, 1, 5, 3, 3. Here we have 4 non-negative numbers adding up to 12. So this would be like 1 goes in the first bin, 5 balls in the second bin, 3 in the third, and so on. So if 0 is allowed, as it was in the last example, we can just use our formula, which was n plus r minus 1. Choose r minus 1. Here, n is the number of stars or balls, in this case, what we're adding up to, which is 12. And r is the number of bars, or it's the number of bins, there are 4. Minus 1, choose 4 minus 1. So the answer to this is simply going to be 15, choose 3. So you can just put 15C3 on your calculator, get 455. That's the number of different solutions like this to the problem. I just want to point out that 1533 is considered a different solution then 5, 1, 3, 3. It's different than 5 going in the first bin, 1 going in the second bin, and so on. All right, let's now do the same problem, but this time none of these numbers is allowed to be 0. So if this were a balls in bins problem, we still have 12 balls, but each of the bin has to have at least one ball. And that's what this means. Xi is greater than 1 for all I. It means each of these has to be greater than or equal to 1. So in terms of bins, each of these bins has to have at least one ball. So why don't we start by satisfying that requirement? We're going to put one ball in each of the bins. So then I'm going to introduce a new variable. So y1 is going to be how many additional balls get placed in bin 1, and then y2 how many additional in bin 2, and so on. We're finding the number of non-negative integer solutions to this equation here. But of course we can make it simpler on ourselves. We can subtract 4 from both sides. We're really finding out this. So now it becomes a problem to solve that's exactly like the one we did there. After we've put one ball in each bin, there are 8 balls left. There are still 4 bins. And then on the bottom, it's 8 plus 4 plus 1, which is 11. Choose 4 minus 1. So this time, the answer will be 11, choose 3, which gives us 165 possibilities. All right, let's now look at a more worded problem. So I have 20 identical lollipops to distribute amongst my 5 favourite students. How many ways can this be done if each student must receive at least 2 lollipops? So again, we have identical lollipops here, just like in previous examples, we had identical balls. So this is combinations with repetition. So we can repeat. So some student can get the same lollipop more than once. A student can get 3 or 4 or 5 lollipops. So combinations with repetition, we use stars and bars. So we're going to label the students x1, that'll be how many the first student gets, plus x2, plus x3, plus so on. Now, we are told that each student must get at least 2 lollipops. So let's get that condition out of the way. If the 5 students get at least 2 lollipops, I can start by handing out the 10 lollipops, 2 to each student. And I must give out 20 in total. So I can subtract 10 from each side and get this. So you can see all these problems are essentially the same. I'm figuring out how many non-negative integer solutions, non-negative because I can't give any student a negative number of lollipops, how many non-negative integer solutions are there to this equation? It's just like I have 10 identical balls and I'm distributing them into 5 bins. How many ways can it be done? Well, this is exactly the same as what we did in the previous slides. We're going to use stars and bars. It is the number of balls, or in this case lollipops, plus the number of bins minus 1. Choose number of bins minus 1. It is 14. Choose 4. So putting that on our calculator, there are 1,001 different ways. So again, each of the different ways could be like the first 4 receive 2 lollipops each, and this person receives 12 or whatever. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.